Okay, let's try this again. I just recorded it and was apparently on mute the whole time. All right, so I just had a Zoom meeting with a group from class. They are working on their data analysis plan assignment. They said that they thought that it was helpful in the previous video, how I went through the first two questions, but that it would be even more helpful if I would go through one of each of the possible types of answers so that they could see how does this kind of test play out in our data. All right, and so that's what I'm going to do in this video. All right, so I have, things that I think you need to do this assignment. You need the data analysis plan. You need this test of table of appropriate statistical tests, and it would be helpful to have the survey itself. All right, and of course, you don't need to have all these things printed out, but having them available to you to look at would be helpful as you went through the assignment. All right, two of these I've already done, but I'm just going to go through it again so that if you're just looking at this video and not the previous one, then you will still get this information. All right, when you're doing these questions, the things that you need to be paying attention to, the question itself, all right, but also this number here in parentheses, it's going to show up in every question, somewhere in the sentence, sometimes in the middle of the sentence, sometimes at the end. It's telling you, use that question from the survey to use the data from this question on the survey to answer this research question. So in this question, we're looking at Q1. Have you ever been diagnosed with ADHD? All right, and so this question is asking, the National Institute of Mental Health reports that 11% of children aged 4 to 17 in the US have been diagnosed with ADHD. Are Ole Miss students more likely to have been diagnosed with ADHD than this American average? All right, and so it says to use the data from Q1 to answer that question. So when we're trying to decide what kind of test we need to look at this and ask ourselves, is this question asking us to divide our sample into groups based on how they answered a survey question? All right, sometimes people will look at this kind of question and say, yes, we have two groups, Ole Miss students and children aged 4 to 17. Did children aged 4 to 17 take our survey? They did not. All right, and so we are not dividing our sample into groups. We're looking at all Ole Miss students, and we're asking, are the answers provided on our survey from everyone who took the survey different from this external reference point? All right, so I have no predictor. I'm not dividing my sample up into groups. All right, and so my answer now has to be one of these three things. All right, a chi-square goodness of fit, a one-way t-test, a paired samples t-test. The way that I'm going to decide which of these tests to do now is I have to ask myself the outcome, the thing these Ole Miss students answered that I'm interested in, was this measured on a categorical or a continuous response scale? In this case, the question tells me that I'm looking at their answers to Q1, right? Are they diagnosed with ADHD or not? This is what the question looks like on the survey. Have you ever been diagnosed with ADHD? Yes or no? This is a nominal response scale, which means it gives us categorical data. All right, and going back to this sheet, when we have no predictor and a categorical variable, we need a chi-square goodness of fit test to do this. All right, and the first page of the assignment says, if the correct answer is chi-square goodness of fit, you need to tell me what your expected distribution is. In this case, if Ole Miss students were just like this national average, we would expect 11% of them to say yes, which means we would expect 89% of them to say no. All right, so there's our expected distribution for this question. And because I'm here making this video, let's just provide all the details. What this chi-square goodness of fit test is going to do is we're going to have our expected distribution, which is coming from the US average. In that US average, 11% of children were prescribed, 89% were not prescribed. We're going to compare that against what we observed, all right, from Ole Miss students. Whoops, spelling. We don't know this yet. All right, I'm working right now before I started this video on cleaning up the data set so that we, even though I'm not requiring you guys to do the analyses, I'm still going to post the data set on Blackboard so that if you want, you can go through and do the analyses, compare them to the answers that I'm going to send you so that if you are trying to learn SPSS, you'll have this information. right? But what we're going to do is we're going to compare the pattern of yeses and nos that we observe among Ole Miss students. We're going to compare it against this national average, and we're going to ask, are these two patterns equal or are they different from each other? All right, and so that's what this chi-square goodness of fit test is going to do for us. All right, but for the data analysis plan, all you have to answer, on your Word document that you're making, you will just write number 1, chi-square goodness of fit, 11% yes, 89% no. All right, so that is one of our kinds of tests now. I'll put a check mark here. All right, the next question says, what proportion of the sample has a legal prescription for ADHD medication? All right, the key language in this sentence is proportion of the sample. Because the sample is explicitly being referenced, that means we're looking for a sample statistic, all right, or a descriptive statistic. We want to know not an inference about the entire student body, but just specific just to the people who took our survey. How many of them say they have a legal prescription for ADHD medication? The two descriptive statistics that we have as options are frequency or mean. All right, we're going to do frequencies when we have categorical data and means when we have continuous data. So we have to figure out Q3, is that categorical or continuous? All right, so we turn to the survey. Here is Q3 on the survey. Do you have a legal prescription for any brand of ADHD medication? Yes or no? All right, this is a nominal response scale, which produces categorical data. When we have categorical data, and we want to report some descriptive statistic about what our sample is telling us, we do that by reporting frequencies or proportions. So our answer here would be frequency or proportion. You could say either word, it wouldn't matter. Okay, so that's what a frequency question would look like on this assignment. All right, let's jump down to number 6. What is the relationship between possession of a prescription and likelihood of current use? All right, remember our first question here, this doesn't reference the sample, so we know that we're going to need one of these inferential statistics. The question is which one? And our first thing that we have to answer is, do we have a predictor here? This phrase, what is the relationship, tells us, yes, we have a predictor. We want to know, does someone's answer to one question predict their answer to a second question? All right, and in this case, we want to know, is there a relationship between whether or not they have a prescription? All right, so does whether or not they have a prescription predict their likelihood of current use? All right, whether or not they are currently using that medication. All right, so does their answer on Q3 predict their answer on Q8B? If I knew their answer to this question, could I predict their answer to this question? If I could, that means there's a relationship between these two variables. If I can't use this to predict this, that means there's no relationship. These two things are unrelated to each other. All right, so we have to find out. We know we have a predictor. All right, so we are in the realm now where there's a predictor. So it's going to be one of these 3 tests. The question is, which one? All right, first we need to find out what kind of variable, sorry, it's hard to see all the papers. What kind of variable is this predictor variable? All right, so we turn to the survey. Do people have a legal prescription? It's a yes or no question. So that's a categorical predictor. So we're going to divide people into groups based on their answer to this categorical variable. A group of people with prescriptions, a group of people without prescriptions. And we want to know, how does that affect their answer to Q8B? All right, this is written up here. All right, so question 8 on the survey asks, how often do you take ADHD medication now? And this is on an interval response scale that ranges from 1, never, to 7, daily. So this is continuous data, but I recoded that continuous data into a categorical variable. So if they answered more than never, all right, so between less than once a month and daily, they were coded as 1, a current user. If they said they never take this drug, they are coded as no, a not current user. And this is Q8B. It gets referenced all the time in the data analysis plan. So know that it's referring to this, all right, a categorical variable. All right, so now we have a categorical predictor, whether or not they have a prescription, and a categorical outcome, whether or not they are currently taking the drug. When we have a categorical predictor and a categorical outcome, we are in this cell, all right, and we need a chi-square test of independence. if thinking about the math helps, here's the math on this chi-square test of independence. Sometimes it's easier for me to think about numerically, what am I trying to do? And then think about the test that does that. All right, so what a chi-square test of independence is going to do is it's going to create this crosstab table. Right? Do people have, this is Q3, do people have a prescription, yes or no? So we're dividing people into those two categories. And then we're looking at their answers to Q8B. Do they currently take the drug, yes or no? And what we're looking at is the pattern of yeses and nos about whether or not they currently take the drug the same for the people who do have a prescription as for the people who do not? All right, and so basically what we're asking is, does having a prescription affect whether you currently take the drug? All right, so if everyone were behaving legally, then the only place where we would see anyone saying that they take the drug is right here. People who have a prescription would say they're currently taking the drug, but we know, I mean, without even looking at the data, we know that there are people who do not have a prescription but are taking the drug. And the question is this proportion as big as this proportion? Or maybe it's bigger, we don't know yet. All right, but that's what we're looking at in this chi-square test of independence. All right, if you know if someone has a prescription, could you use that information to predict whether or not they're currently taking the drug? All right, is there a relationship between how people answered this question and how people answered this question, where both of these things were measured on nominal response scales? Okay, chi-square test of independence. Let's put a check mark on that one. All right, number 7. Who is using these medications more frequently, men or women? All right, so first question you should ask yourself, is this question asking me to divide my sample into groups based on how they answered a question from my survey? All right, and when you ask yourself that question, you should say, yes, I'm comparing these two groups of people, men versus women. I'm getting that data from how they answered Q32 on the survey. All right, and we know without looking at the survey question that this is categorical, right? Did they circle men? Did they circle women? All right, so we are in this column of having a categorical predictor. So we're either going to do a chi-square test of independence or an independent samples t-test. In order to determine that, we have to ask ourselves, what is it that these men and women are doing that we're interested in? All right, are they doing something that we measured on a categorical scale, or are they doing something that we measured on a continuous scale? All right, and so this reference is who's using it more frequently, question 8. All right, so we just saw that, but let's turn back to question 8. How often do you take ADHD medication now, right, on this 1 to 7 interval response scale? This is a continuous measure. All right, so we have a categorical predictor, a continuous outcome. That means we need an independent samples t-test. All right, what this test is going to do for us they're testing the tornado siren now, which honestly, after the last couple of days is not funny. It like made me nervous for a second, even though it's sunny and nice outside. Okay, independent samples t-test. What this test is going to do, sorry, you guys probably can't hear the siren because the microphone's not good enough. The independent samples t-test, we are going to calculate the mean in our sample for the men, and we're going to calculate the mean in our sample for the women, the mean of question 8. All right, how frequently are they taking this drug? And we're going to ask, is the mean frequency for the men equal to the mean frequency for the women? Right, and we're going to use the answer that we find here to make an inference about the population means. All right, based on what the sample said, do I think at the population level that men and women are taking this drug with the same frequency, or do I think that one gender is taking it more often? All right, that's what this independent samples t-test is going to tell us. All right, so we can check off independent samples t-test here. All right, the next one I've highlighted, number 10. Is there a relationship between age and frequency of ADHD medication use? Here we have that magic phrase, is there a relationship? When we see that, we basically know it's going to be a predictor here. All right, so we are back to it has to be one of these 3 because we have a predictor variable. The other way that you can ask yourself, do I have a predictor or not, is if a question has two variables in parentheses at the end of the sentence, that means you have to do a test that uses two variables, which means it has to be one of these three or the paired samples t-test, which has no predictor but two continuous variables. However, if it says, is there a relationship, that means predictor. All right, paired samples t-test don't look at relationships, it looks at differences. All right, so we know we have a predictor here. Is there a relationship? And the relationship we're looking for is we're asking, does age predict frequency of medication use? So if I know how old someone is, could I use that information to predict how often they're taking ADHD medication? Question we have to ask ourselves next is our predictor variable, age, being measured on a categorical or a continuous response scale? All right, and so that's Q33, tells us right here. We know that Q8 is that frequency of use, so Q33 is age. Let me get all the way back there in the survey. My survey's out of order. All right, Q33 is asked, what is your age? And they just write in a number on a blank line. All right, so this is ratio, which gives us continuous data. All right, so we have a continuous predictor variable. And without even looking at the second variable, we know that we have to be doing a bivariate correlation here because it's the only test that we know to do when we have a continuous predictor. All right, so 10 is going to be correlation. You don't have to write bivariate every time. I know what you mean. All right, what this correlation is going to do is it's asking, as people's age increases, so as that first variable increases, does something predictable happen to how often they take the drug? And that predictable thing could be that as you get older, you take it more often, or it could be that as you get older, you take it less often. We don't know. Both of those are possibilities. But we're asking with this correlation, does this pattern exist? All right, because the other possibility is that these two things are completely unrelated to each other, that how old you are has absolutely nothing to do with how frequently you take the drug, in which case the correlation will come back with a very small correlation coefficient, a very large p-value, and you would conclude there's no relationship between these two things. Someone's age has no effect on how frequently they take the drug. All right, but we're going to use a correlation to examine this when we have a continuous predictor and a continuous outcome. All right, we're not technically dividing into groups here, but we're just saying as someone's age increases, is there a predictable response with how frequently they take the drug? Do the two tend to increase together? Or as this one increases, does frequency tend to drop? Or is there no relationship? All right, that's what the correlation is going to tell us. All right, so correlation. Let's look for our next highlighted question. All right, number 14. Are any of the listed reasons significant influencers in students' decisions to take ADHD medication for the first time? Looking at Q7A through H, actually this should be a G because this was one of the questions we talked about in our Zoom meeting. Let's look at Q7. Oh no, now I really got things out of order. Sorry, my survey now jumps from page 8 to page 28. Finally, thank you for your patience. All right, here's this question. How strongly did each of the following reasons influence your decision to use ADHD medication for the first time? All right, and so things that we brainstormed could have influenced their decision to use it the first time. Their doctor actually prescribed it. They were feeling stressed out. They wanted to do better in school, peer pressure, recreational use, desire to lose weight, or they were just curious what would happen. And so looking at this question and trying to figure out what we're going to do with this information, the first thing that you should notice is that only one variable is identified here. All right, so this says test one at a time. Is a doctor's prescription a significant influence? All right, so we just have the data from Q7A, in this case, the doctor's prescription, and we're trying to answer some question about how people answered that one question on the survey. All right, it doesn't specifically reference our sample. All right, so we're not looking for a descriptive statistic. We are going to do one of the things in this table. We have no predictor variable and only one outcome. So that means we have to be doing one of these two tests right here, either a chi-square Guinness fit test or a one-way t-test. All right, and so to decide, we have to look at their answer here and ask ourselves, is this a categorical measure or is it a continuous measure? All right, and this is a continuous measure. It's an interval response scale from 1 to 7. And so what we're going to do is we're going to look at the mean on this question and ask, does this mean suggest that the doctor's prescription was influential or that it was uninfluential? All right, and we're going to use a one-way t-test to answer that. All right, one-way t-test. When your answer is one-way t-test, going back to the first page of this, if the correct answer is one-way t-test, you need to also tell me what your test value is, right? What number will you compare the sample mean to? In this case, what this question is asking is, here's the midpoint. I don't know if you guys can see the bubbles that people could have answered here. If people answered a 4 on average, that means that they're saying that they were sort of neutral. The doctor's prescription had a neutral influence on their decision to use. It was not influential, it was not uninfluential, they were just neutral. And what we want to know when we're doing this test is, was the mean significantly greater than 4, suggesting that a doctor's prescription was influential to some extent, right, in their decision to use? Look at the question. Are any of the listed reasons significant influencers? Did this thing influence their decision, right, significantly, greater than 4? Or maybe the mean is less than 4, saying that this thing had no influence. It was uninfluential in their decision to use this drug for the first time. This this one-way t-test is going to do this for us. We're going to calculate the mean in the sample, which will be X bar of Q7A. And we're going to ask, is that sample mean equal to the midpoint of the scale? If it is equal to the midpoint of the scale, that means that people are saying the doctor's prescription was neutral. It was not influential or not influential. It was just neutral. All right, they basically didn't think about it at all. And if the mean is not equal to 4, we want to know, is it significantly greater than 4, suggesting that a doctor's prescription was influential, or was it significantly less than 4, meaning it was not influential? All right, and that means that this is our test value. This is the number that we're going to compare our sample mean to. So when you answer this question, you would say one-way t-test, test value equals 4. All right. This way of using the one-way t-test is something that we talked about in the comparing the t-tests set of slides that are on YouTube. But it's also talked about in the second SPSS video where I go through the worksheet and we talk about the logic of this test and see it being used in a practical sort of way that I think you can wrap your head around what it's meaning there. So if this use of the one-way t-test is tripping you up, I would suggest looking at that second SPSS video. If you don't want to watch the whole thing, it's what gets done at the very end. All right, so you could probably watch like the last 10 minutes of the video and it would show you this one-way t-test being used in this way to help you understand conceptually what's happening here. All right, so we have a one-way t-test done. All right, let me find my next highlight. I had to go through and find one of each kind of test. Do students believe that ADHD medication is safe? Nope, wrong one. Do students believe that ADHD medication is less safe for those not prescribed than for those prescribed? All right, so this one, we ask ourselves, is this asking me to divide my sample into groups? I'll pause while you think about it. No. All right, and the way we know no is because it just says do students. All right, it's not asking about different types of students. It's just saying do students, all of them. Do they think that ADHD medication is less safe for those not prescribed than for those prescribed? This is one place where I think it's super important to have the survey open while you're doing this, because maybe you look at this and you say, I have no idea what I'm supposed to do here. This is really confusing. It might make more sense if you look at the actual survey question, survey questions. All right, so here are the survey questions. Question 20, they're identified here at the end, Q23 and Q22. Question 22, do you believe stimulant medication is risky or dangerous for people who have been diagnosed? All right, and then they answer, it's extremely safe to it's very dangerous. Interval response scale, this is a continuous measure. So we have, first thing, their opinion about the riskiness of this medication for people who actually have ADHD. Then we look at question 23. Same question. same scale, extremely safe to very dangerous, same continuous response scale. Do you believe this medication is risky for people without ADHD? All right, and so what this question is asking is, do students believe that ADHD medication is riskier for people without ADHD compared to people with ADHD? This is not asking us to divide our sample into groups. It's saying everybody. Is the way that they answered question 23 different from the way they answered question 22? Is their mean perceived riskiness on question 22 equal to or different from their mean perceived riskiness on question 23? All right, so is the mean riskiness for people with ADHD, remember this is a perception, this is not objective. Students' beliefs about riskiness is not actual riskiness, but this is perceived. Is the perceived riskiness of this drug for people with ADHD equal to the perceived riskiness for people without ADHD? All right, and this is Q22 and Q23. Is the mean of Q22 equal to the mean of Q23? We have a test that does this for us. We have no predictor. We have two continuous outcomes. We want to know, is the mean of question 1 equal to the mean of question 2? Or in this case, is the mean of question 22 equal to the mean of question 23? We use a paired samples t-test to do this. I made a video and posted it to YouTube. Maybe you watched it, talking about the difference between a paired samples t-test and a correlation. And it was talking about people's liking for Moe's and people's liking for Chipotle. So the correlate here is the mean liking for Moe's equal to the mean liking for Chipotle? All right, and we use a paired samples t-test to do that. All right, so here for number 30, your answer is paired samples t-test. All right, last test that we haven't talked about yet. Question number 34 asks, on average, how many doses of ADHD medication are members of our sample? Members of our sample taking in a week. All right, this is explicitly referencing our sample. All right, so we know that we need a sample statistic. We're not making an inference to the broader population. We're just saying the people who took our survey, how did they answer this question? Hopefully I can find Q11 in less than an hour. In a regular school week, on average, how many doses of ADHD medication do you take? Ratio response scale, right? They're just entering a number. When we have continuous data, the sample statistic that we generally use is we report the mean, right? So the answer here is mean, right? We just want to know what is the mean number that was provided as the answer to Q11, all right? On average, the people who took our survey, what are they saying, all right, about this? Their frequency of taking medication during a normal week. All right, that is one of every kind of test now. So every group should have at least 8 questions right on this assignment now. One thing that I talked about with the group, and they said they thought it was a good idea, so I'm going to use their answers as a proxy for everyone else. I'm going to go through the data analysis plan and make the key. And once I make the key, I'm going to send you guys an email that says how many answers are frequency, how many answers are mean, how many answers are chi-square goodness of fit. So I'm not telling you which question has that as an answer, but you will know, if you go through and you say, oh man, I only had mean for 2 questions. I have no idea how many answers, how many of these questions mean is the correct answer for. But let's say you only get 2. You can look at this and say, oh, okay, there only should be 2. So now I don't feel uncomfortable about that anymore. Some of these tests get used much more often than others, right? And I told you guys to use interval and ratio response scales wherever possible, because the t-tests I think are easier to interpret once you see the data. So I'm guessing, although I don't know yet because I haven't made the key yet, I'm guessing that the t-tests are going to show up more often than the chi-square test. I made no effort when I wrote this assignment to come up with questions in some even distribution of these possible answers. I just wrote questions that were interesting to me anyway and could be answered using our data, and whatever the answer is whatever the answer is. All right, I didn't consider what the answer would be when I wrote the question. All right, so we're going to see some non-equal distribution of these as the possible answers, but I will make that and send it to you. I'm a little concerned that this might actually make things worse, right? That if you have a lot of wrong answers, that you could look at that and say, oh, well, all of my wrong answers, you know, that's all of my chi-square tests, so now I'm not going to answer chi-square for anything else, and now you've just gotten like even more things wrong. I'm a little concerned about that happening. So what I would recommend doing with this information that's going to be available to you is to answer the data analysis plan without looking at the numbers that I'm going to provide to you, and do the best that you can and try to understand the patterns as much as you can. And when you think that you have everything right, count up how many you have of each test and then compare it to this list. All right, don't use this as some sort of checklist as you're going along, because if you think you've answered frequency enough times, but those are wrong, then that will prevent you from answering frequency later when it would have been right. All right, and hopefully you understand what I'm saying there. All right, but hopefully this video was helpful. Hopefully you have started this data analysis plan. All right, it's due in 6 days now by midnight. This is not a simple, you know, do it in one night kind of assignment. You need to have watched the statistics lecture videos, or, you know, watched them on Khan Academy, or read the textbook, or done something to familiarize yourself with this material before you can do the assignment. And you cannot do that all right, the night that this is due. All right, so please start this sooner rather than later. All right, and then go back to watching Tiger King. And I want to say I'll see you guys soon, but obviously that's not going to happen. So I'll see you one day, hopefully at graduation. I hope you guys are all well. If you need help when you're doing this assignment, I'm not going to give you all the answers, but I'm happy to do some Zoom chat to help talk you through different kinds of tests that you might be having trouble with. All right, stay safe, stay in your houses, wash your hands. Bye, guys.